Hello, this is Alan Elliott, and this is SAS Essentials, Mastering SAS for Data Analytics, 3rd edition. This is Chapter 20, Creating Custom Reports, Part 2. In the last tutorial, we learned how to create reports using PROC TABULATE. In this tutorial, we'll be learning how to create custom reports using PROC REPORT and to create custom reports using the data step. As usual, if you'd like to follow along with the examples in this tutorial, please download the data files at the location indicated here on the web. Let's begin. This is section 20.2, using PROC Report. PROC Report is a procedure in SAS that allows you to create professional data reports and summaries. The syntax for PROC Report is a little different from most statistical procedures because it has a particular emphasis on creating the columns of a report. So here we have the typical syntax, where you have PROC Report, data equal, and then as typical, the data set name, followed by some options. And then we define the columns in that report. So we have a column statement, and we have columns, variables, and specifications. Define the column and certain attributes. We can compute values in a column and some compute statements, and then we end a compute statement if we've begun one. So here let's talk about the column statement. The column statement is used to identify variables of interest to be reported in columns and to specify headers and groups. So every column you want to display in the table must be indicated in the column statement. So a simple report would be, so PROC report data equal, for instance, mysas.labs. And notice here the no FS, that's an old statement. We're not going to talk about that. It's a leftover statement from a previous version. Just include it. It just makes things simpler. And then column, brand, city miles per gallon, highway miles per gallon. So this is a simple report that contains 3 columns. It's very similar to a PROC print so far, but we're going to be able to enhance this report using a define statement. So the define statement is used to specify the appearance of the columns. So for instance, its syntax is define, and then the report item and some options. So the define specifies variable attributes that determine how it's displayed. So options are follow a slash. And the options can be of several types. First of all, options can describe how to use a variable, how to control the column headings, how to customize a report item, and other items for a report item. For example, define age. So here we have a column called age, and we're going to define a label here, display a label, for instance, and then format 6.1 defines how the numeric variable age is displayed in terms of a SAS format. Now here are some PROC defined statements, PROC report defined statements. So the display statement, we just looked at that. The order statement orders the data, informs groups. The group consolidates observations using specified variables. For example, define brand/group displays records grouped by brand. Analysis defines a variable used to calculate a statistic within the cell of a report. Compute and end comp, or in compute, begins and ends code segments that calculate a data value. We'll see some examples of that. And then across creates groups across a page rather than down the page. Here are some defined statements for the options attributes. So here we have format equal format. We're very familiar with that. The label statement, we're familiar with how to use that. And we can also split the title. We've seen that before. Statistic name, we can name any statistic we want to use that would be used, for instance, from PROC means. We could say things like n, mean, sum, standard deviation, any of those that would be used in PROC means. Order equal order type, data, formatted, FREQ, internal. We've used all of those before. And the descending option to reverse the normal ascending order. Okay, let's look at some more about the display options in the define statement. So the define statement is the a var, a variable, slash display options. So here we have one that we actually saw before, but define, and then the variable name age slash display. And we can do several things here. One of them is we can define a label, here in this case age slash 2000, and a format, format equals 6.1. So just as the split character slash in a label indicates to go to the next statement, so the label age slash 2000 is displayed on 2 lines. And we've seen that in previous procedures. So note in the label statement that the default split character is a slash. However, it can be defined as a different character if we want to. In PROC report, we can say, for instance, split equal asterisk to make that the split character. So in the following hands-on exercise illustrates some of these options. So let's open up the program file areport1.sas, and we see here PROC report, where we're using the data set called cars, and we're defining some columns: brand, model, city miles per gallon, and highway miles per gallon. And we're defining city miles per gallon using the following options. So we're going to display it using format 6.1 and give it the header city slash miles per gallon. So that will be appearing on 2 lines, city on one line and then MPG on the other line. And here we see what we will get there. So here we have the 4 columns we asked for: brand, model, city miles per gallon, and highway miles per gallon. So notice that all of the column headings are just the names of the variables in most cases, except for the one that we defined, which was the city miles per gallon. And in that case, we defined the column heading, and so we get a different column heading. Plus, notice here that we also defined a different format. So we got the 6.1 format, as we saw here. So again, the define allows us, or the display allows us to specify what the column is going to look like, or what the data and the heading in the column are going to look like. And we can add display options for the other variables as well. So here's an example. In this case, we're adding a variable called engine size. And we're going to define, we already defined our city miles per gallon, highway miles per gallon, and engine size. And as we can see here, we added this new one called engine size. And again, it's on 2 lines, engine slash size. And so you can, for every column that you have defined here, you can define a format and a label. And again, we didn't define any label for the first 2 for brand and model, and so they just appear as their regular name. We can use the order option in the define statement to define a column variable sorted by a certain variable. And we can also use descend to reverse that order. So for instance, here we have PROC report, again the cars option, 3 columns, and here we have define brand slash order, and then we give it a name brand. And what this is going to do is, as we're going to see, it's going to display the results in order of brand. And so let's see that as an example. Open up the file called areport2.sas, and we can see that that line now is in the file that we just opened, define brand slash order brand. And we also have the other defined statements for city and miles per gallon and highway miles per gallon. And here we have the results. And we see that, notice here that we didn't put the slash in the label, so that the city miles per gallon and highway miles per gallon now appear on 1 line rather than 2 lines. And also notice that the brand now appears ordered by whatever the name of the car is, the brand of the car, so Acura. And it doesn't repeat them, by the way. So here we have Acura, and then a bunch of blanks, and then Audi. And so instead of repeating them constantly until it runs out, it's cleaner looking to simply have the brand name, and then it doesn't change until the brand name changes. And they're in alphabetical order. If we put descending as part of the definition, where we have brand/order descending, then Volvo becomes the first one listed, and then it's in reverse alphabetical order. And there's some other order options we could use. We could use order equal data, which orders it by brand, but in the order in which the brand was originally in the data set. Occasionally you might want to use that. In this case, if you look at the raw data set, you'll notice that Toyota was the first one in the data set. So in this case, Toyota is the first one that appears in our report. Now let's use two order options. So in this case, notice here, and we have two defined statements. We have a defined brand, order equal data of brand, and then and so that's going to order it in the order in which it appears in the data set. And then we also have a defined statement, cylinders/order, which is going to order it in the number of cylinders within that brand. And we see the results here, where Toyota is the first one in the data set, and then the first listing is Toyotas with 4 cylinders, and then it'll have the Toyotas with 6 cylinders and so forth, and then it'll go to the next brand. Now, if we remove the order equal data, so it's no longer going to be Toyota, instead it'll be in alphabetical order, then we have Acura as the first one, and again we see Acura then appears, and we have 1, 2, 3, 4, 5 different Acuras with 4 cylinders, and then we have some with 6 cylinders. So it ordered it by brand first, and then by the number of cylinders within each model within the brand. All right, let's take a look at the group option in the defined statement a little more. So here let's do example 20.9. So open up areport3.sas, and in this case, what we're going to do is define a column statement brand where we have city miles per gallon, highway miles per gallon, comma, mean. Now what this does is that mean requests the mean for both city miles per gallon and highway miles per gallon. Now if we hadn't requested mean, all miles per gallon would be listed instead of means. So it's important to keep that in mind. And then we have a defined statement. We're going to order it by group, and then the city miles per gallon with some things we've already seen. So let's see what that looks like. So again, we have city miles per gallon and highway miles per gallon, and the mean. So here we have the mean Acura city miles per gallon is 20.6, and the mean highway miles per gallon 28.6. And it's reported, it's ordered by brand, as we can see in alphabetical order. And then the mean gives us the mean of all of the Acuras in the data set. And again, notice here the comment, it says, notice that the format defined for mean for city miles per gallon is also used for highway miles per gallon because of the statement, they're in parentheses. So city miles per gallon and highway miles per gallon are in a parentheses, comma, mean. And so what that does is it applies the mean option to both city miles per gallon and highway miles per gallon. If we took out the parentheses and said city miles per gallon, comma, mean, highway miles per gallon, comma, mean, then notice here that the column statement only has city miles per gallon and highway miles per gallon separate for the mean, but the format assigned only applies to city miles per gallon. So here we have sort of a separate thing. City miles per gallon has the format still applied, and then you back up and show you where we define city miles per gallon as 6.1, and that still applies, but now it's lost for highway miles per gallon. But if we define them both within the parentheses as mean, then it applies that format to both of them as it did right here. So you just got to be careful, when you're applying a statistic, if you apply it to both of them within a parentheses, which is typically what you'd want to do, save you some programming, do it with them in parentheses, unless you're doing something separately, and then you obviously have to do them each one at a time. All right, let's add another defined statement and for highway miles per gallon. And in this case, we do this to correct that column here to make sure that both columns then are correct. And again, this just gives you, requires you to do more coding. If we had put them highway miles per gallon and city miles per gallon in parentheses, we could eliminate having to code this extra line. Now let's change the brand to cylinders in both the column and defined statements and rerun to verify that the report is now grouped by the number of cylinders. So here we have column cylinders, miles per gallon mean, highway miles per gallon mean, and we're to define cylinders by group. So here we now have the data ordered by cylinders and then the mean miles per gallon. Notice here that there's one cylinder that's a -1, and that's a rotary engine, and those are, I believe, Mazdas, and so we have a sort of peculiar one there. But as we see now, it's ordered by cylinders, and then we see then typically, as we would expect, we get better miles per gallon the fewer cylinders there are. As we go higher, typically we get lower miles per gallon. All right, now let's add another column, column cylinders in. So we're going to N gives us the number of models within this calculation here. So this mean that we've seen here, we didn't know how many cars went into that mean. So we might be interested, you know, how many cars are in that. And so we define N as a column, but we also might want to in the cylinders by group, we might want to order it by frequency so that we're starting out with the lowest number. There's only 2 rotary engines, but as we go forward, you see that most cars are 6-cylinder, 453 or 6-cylinder, and so we can see that you know, as things go forward, then the perhaps the mean may make a little bit more sense the more cars there are. When there's only 2 cars, you know, you have maybe a lot of variability or something within there. Okay, now let's look at the analysis option in the defined statement. So we have define var/analysis. This option allows you to display a statistic for a specified column, and we discussed this earlier, where you can create, display any statistic, a mean, standard deviation, etc. We're going to just show you mean just to be simple. So here we have a PROC report, and notice the defined statement here in red, define city miles per gallon /analysis mean. Now all that's going to do is display city miles per gallon, but instead of the sum, which it normally would do, it's going to display the mean. So here we see the result of this code, and what we see here is that city miles per gallon, the city miles per gallon is reported and formatted with 6.1, but the highway miles per gallon is not changed, and the sum is reported like it has been in the past. Now we can create a new code, highway miles per gallon /analysis mean, and then now we have both columns reporting the mean. Let's look at including engine size. So here we have column, brand, city miles per gallon, highway miles per gallon, and we're going to include engine size. And we define engine size, again, /analysis mean, and again, we're formatting it and giving it a name. So now we have the mean of engine size for Acuras and Audis and so forth. Now, this is a little bit more of a complicated one, but it can be very useful, and that is using the compute option. So compute and end compute begin and end a segment of SAS code that allows you to calculate values of new variables. Let's look at this using the program file areport5. So the things in red are the things that are really added that we haven't seen before in this code. So here we have PROC report. We have columns brand, city miles per gallon, city miles per gallon, the mean of it, highway miles per gallon, the mean of it, and then ratio miles per gallon. So we've added a new column called ratio miles per gallon. However, ratio miles per gallon is not a variable. So how is it going to display that column? the way it's going to display it is we have to define that. So here we have a defined ratio miles per gallon slash computed. So we're telling SAS, okay, there's not a variable called ratio miles per gallon, but I'm going to compute it. And I'm going to give it some formats, etc. Now we have to tell SAS how to compute it. And we say, and we use that with this little section here where we start with compute and end with in comp or in compute. So we say compute ratio miles per gallon, and ratio miles per gallon equal, now this is the sort of interesting part, is underscore C2 divided by underscore C3. Now, what is C2 and C3? That's what is sort of complicated. C2 and C3 are the columns. So if you go back up here to column 2, C2 is city miles per gallon. Column 3 is highway miles per gallon. So C2 divided by C3, or underscore C2 divided by underscore C3, is really city miles per gallon divided by highway miles per gallon. So it's not exactly obvious how that works, but that's how that calculation works. All right, and then this explains that, that C2 and C3 refers to city miles per gallon and highway miles per gallon. All right, now some new statements. PROC report, where we have now a new split statement, and we mentioned earlier that you could define a new split statement. Here's an example of that. We're going to use the tilde as a new split statement. And so we're going to show a defined statement, ratio miles per gallon, and we computed it. And now we say ratio tilde city slash highway miles per gallon. Now the reason we did this was because slash is the default split character. So we can't have city slash highway in a title because it would split it. So we have to define a new split character so we can use a slash within our definition. And so this would be one reason why you would redefine what the split character would be so that you can create a label like you would want it. And then of course the compute statement there. And then this gives us what we want. As we can see here, the result where we have the two columns that are the mean and then the ratio city slash highway. And we get the column now that we want, which is the calculated values. All right, let's look at the summary of using the compute to the end ratio, engine ratio. So here we have the columns where we are going to create a new column called engine ratio. We're going to define engine ratio and tell it it's computed. And then we're going to have a compute statement. Engine ratio is C2 divided by C4 and in compute. And notice here we also had the ratio miles per gallon. And so here we have multiple compute statements here and multiple new columns. We've defined ratio miles per gallon and engine ratio. And again, we have now the two columns that we have computed. All right, so let's do a hands-on exercise 20.12 and open up a report 6.sas. In this case, we're creating a PROC format where we're creating a format called format SUV. 0 means it's not an SUV, 1 means it is an SUV. And we're going to create PROC format where we're going to have columns brand, city miles per gallon, comma SUV, highway miles per gallon, comma SUV. So what that's going to do is we're saying, give me city miles per gallon broken down by SUV, yes or no, and highway miles per gallon broken down by SUV. And here we have our define statements. Now notice here in red at the bottom, define SUV slash across by SUV. We haven't seen this across before. And so what this is going to do is we're going to see allows you to create a column for each unique item. And then we're going to define SUV using that if format SUV that we defined in the PROC format statement above. So again, what we've done is we've created a format called FMT SUV. In our columns, we have 3 columns: brand, city miles per gallon, and highway miles per gallon. But we also have this comma SUV that we're going to be using in a define statement slash across, and we'll see how that now works. So here we have the brand, Acura, Audi, BMW. We have city miles per gallon, and then by SUV. And notice then the across, what that does is it breaks it down. So by our format, not SUV and SUV. And same with highway miles per gallon. By SUV, not SUV and SUV. So the across broke it down across rather than stacking it, on top of one another like we've seen before. So the across comes in handy if we want to create columns that are broken down by certain values within a particular variable. Let's add another column just to show you how easy it is to add columns to once you've got the hang of this. We can add engine size, again, just engine size, SUV with a defined statement, just like we did on the others. And then when we run it, we get a new column called engine size. And again, by SUV, not SUV, and SUV. Let's play around with it a little bit more and change all the SUV references to automatic to compare miles per gallon engine size for cars with and without automatic transmission. So you can see in red where we've made some changes here. First, we've added a new format called FMT Auto, 0 manual, 1 is automatic. We've changed the comma SUVs in the column statements to automatic. We changed the title from SUV to type transmission, and the defined statement automatic, and then the format we define using the new format we created called FMT Auto. The result is now that we get a brand new report, and this just shows you that you can quickly change your report with just a few options. And here we've changed it instead of comparing whether or not it's an SUV, we've now comparing whether or not it's an automatic or manual transmission. So that gives you an idea of how you can quickly change it or create several reports. Once you create one report, you can maybe cut and paste or copy and paste the code and create several reports. Some additional techniques for PROC report. You can report multiple statistics in the column statement. We saw that we could report mean, but you could also report several. So here we have column, brand, miles per gallon, comma, we had mean, but we could say in parentheses, in, mean, standard deviation. So here we've created multiple, or requested multiple statistics, and you can, again, put whatever statistics you want in that list according to the kinds of statistics we would see typically in PROC means. So let's take a look at that example. Open up the program file called areport7, and here we have the columns brand, city miles per gallon, where we're asking for in, mean, and standard deviation, and then the columns highway miles per gallon and engine size. So we're and then down below in red, we're defining in slash and give it a label in with a format. So a simple addition of some code there. So what that has done is we now have a column or some columns in city miles per gallon where we have in, the mean, and the standard deviation under city miles per gallon. So compare that to highway miles per gallon. In highway miles per gallon, we're simply getting a single number, mean, but in city miles per gallon, we're getting 3 numbers here. So it gives you an example of how you can quickly provide more information within a column. We can do similar columns for highway miles per gallon and engine size as we see here. And you can do this as an exercise, but just do add the same kinds of things for highway miles per gallon and engine size. And again, you can see that you can change all 3 columns where it contains the sample size, or the mean, and the standard deviation. All right, so we can also report totals and subtotals in PROC report. To display totals at the bottom of a column of numbers, use the break and RBreak statements. The break statement produces a summary at a specific break, and RBreak specifies a summary at the beginning or end of a report. So here's a simplified break statement. So we say break either before or after, in the bar or variable, summarize, and then the option suppress. We'll see what that means. And for RBreak, we have RBreak, again, before and after, or after, and /summarize. And so let's see how that works. Here we open up the program file, A report 8, and here we have PROC report, and we define the columns brand, cylinders, automatic, and SUV. And then in red down below, first of all, we define brand and cylinders in our define statement. And then we have break after brand /summarize and then suppress. And then RBreak after /summarize. And then we're saying where cylinder is not equal to -1, we're going to leave out the Mazda cars that have no cylinders. All right, so here we have the break and RBreak, how that works. So here we have Acura. Acura has two types, a 4-cylinder and a 6-cylinder, automatic 2 and 4, and then SUV 0 and 1. The break is used to count the number of cars that are automatic or SUVs. So there are 6 automatics and 1 SUV, and then and so forth for Acura. Again, 27 automatics and 3 SUVs. And then down at the bottom, RBreak. So that's done with the break command or break option. Is used to count the number of cars. And then the RBreak creates the grand total. So down at the very bottom, we see the RBreak. What that created is the grand total of automatics. So there's 753 and 279. So let's just back up for a moment. And again, see the break after brand. So there's brand. So after the brand, we have a break, and we're going to then have a summarize. And again, we'll look at suppress in just a minute. But then the RBreak is at the very bottom. Now, if we leave off suppress, what that's going to do is it's going to repeat the word, the brand at the summary. So here we have Acura and then Acura again. And so depending on, I think the initial one where we don't have Acura twice is cleaner, but it depends on what you want. You can either suppress that second one or not using that suppress option. All right, let's look at section 20.2.1. This is writing reports within a data statement. So this is a third way of creating reports, and this is a customized way of writing reports. So the first two we looked at were very programmed way of using PROCs to create reports that SAS created for us. And this is a way to create much more customized reports where you can actually, create a report that looks anything like you want it to look like. And that is by using the data step and the put statement, along with some other things. So this is another way to create reports. And the way we do it is we use the data step and specify the name null as the data step name, because we're not really creating a data set. What we're doing is we're using the data step to create some output to not really to a file, but to a print destination that we're going to use a file statement to do that. In fact, we're going to use the statement file print that sends the report to the results viewer rather than to a file on disk, although we can do that as well. So when we use the file specification file specification, the report is actually sent to a text file location. So we can send it to the results viewer, or we can save it to a place on disk. And we use the put statements within the data step to create the lines of the output for the report. We'll see how that works. All right, so here's an example of 20.15. Open up the file aput-report1.sas. So you notice we start out with data _ null _. Now again, this is going to create no data set, and we use that simply because data needs to have some data set name, in this case a null data set name. So we're going to say set mysaslib.sumData, so we're bringing in some data called sumData, and we're going to just say put age. So what this is doing is it's showing you within this little data paragraph, we can actually cause some output to happen. So we're going to say put age. Now when we run this, and then we look at the log, we'll see that we just simply get a listing of a bunch of ages, 12, 11, 12, 11, 4, and so forth. So this is not very interesting, but it shows you that we can cause the data step to output some information. So this is more of how this would look if we said file print. Instead of going to the log, it goes to the results viewer, and it looks a little bit nicer, but it's still the same information. It's still pretty boring. So let's try to make that look more interesting. So how can we do that? Again, we say data null. We're using the sum data set, file print. And now let's add to it. Let's enhance this put statement by saying put, and then in quotes, the age for subject, quote, space, ID, quote, is, quote, age. So here we're going to have two variables, ID and age. And then we run that and we get a bunch of lines. The age for subject 101 is 12, the age for subject 102 is 11. So now we're getting something that looks like an actual report. Still a little bit boring, but nevertheless we're getting something output to the results viewer that's beginning to be a little bit more interesting. All right, now let's change the output to a file destination. So you see here in red that we've changed the file print to file and then the actual file name, C:\SAS data output.txt. Everything else is the same. And we run this, and then we can open up the, once we've run it, we can open up the file called output.txt, and this is the contents of that file. And so we can see now that SAS has output this text to the output file. Just a side comment down here, if you're using some sort of network version like the Citrix version, you may have to use a particular kind of file specification other than what we're using here, and that is dependent on what network version you're using. All right, so let's look at how to customize lines of output using put. And we've seen text. We simply can put text in quotes. It can be single or double quotes here, and you say put and then some text. We can include variable names interspersed with text. Just put and then some variable names. We can use the at symbol to move the pointer. So for instance, if I say put at 5, age equal age, what that does is it skips to the 5th column and then puts age equal and then age. So at n means at some number, so at 5. It could be a variable, at some variable name or at expression. So that allows you to variably put information at some column within your output depending on what you want to happen. You can also say plus n or plus var or plus expression. Again, moves the pointer relative to the location. So let's say you're at the 10th column and you say plus 5, then that moves it to the 15th column. The at symbol then holds the output to the current output line. And this is similar to what we saw very early in the text, where we were holding the line so that it didn't, when we were inputting information, so that it didn't go to the next line. We can have the variable as a format, so we can put age 5.1, for instance, to output a variable using a particular format. We can say n star some character. So if I say n put 50 star and a dash, is going to create a dashed line 50 characters wide. All right, so let's look at a specific example. This is going to be an example we're going to build upon, and this is the grade report example. So we're going to use a data set of grades and create a report that includes each student's grade average and a class average. AVE is calculated for each student, the average. So here we have data, grades. We're going to input their name and 3 different grades, G1, G2, and G3. And then we're going to calculate average, which is the mean of G1 through G3. So we're going to have actually 5 variables, name, G1, G2, G3, and average. And here we have 3 subjects, and obviously you can have as many as you want in a class. And then we're simply going to have a proc means output out equal g mean. So we're going to actually create an output file called g mean, where we're going to store the means in this file. All right, so the numbers needed for this upcoming grade report are going to be in this file. So here's the result of that file we're calling g mean. So we see here that we have means and standard deviation and so forth. What we're really wanting is the means. So here we have the means for the 3 students and the average of all the grades. Okay, let's do hands-on example 20.16. Open up the program file APUT report2.sas. In this first section here, these are preliminary calculations to create the macro variable class mean. So the first thing we do here is run the proc means to create the output file, actually a data set called g mean. Notice we're using no print. We're not interested in printing it out. We're simply interested in creating the data set. And then we use that data set, data null, set g mean, so we're using it to capture a particular value that we're looking for. So notice this statement here, if underscore stat underscore equal mean. Now where does that come from? Let's back up, and here we have this column here, stat, and here is mean, and here is average. So if stat is equal to mean, we're going to use this average value. So that's where this is all coming from. If underscore stat equal mean, then call simput, which is going to create a macro variable called class mean using the average, and it's going to round it to 0.101 decimal points. Now we're going to use that information, again data null, set grades, and notice here end equal EOF. So the report uses information from the grades data set. EOF marks the last record in the grades data set. So we're going to use that in a minute. So the table head we're going to call summary of grades. A file print, remember that sends the information to the output viewer. And we're saying if n equal, underscore n equal 1, so that means if it's the first record in the data set, then do, and if you remember from previous use of previous programming, then that means whatever if this is true, then do all the way to the end. So this code here is going to take place when for the first record of the data set grades. So here we have L equal 5 plus, and what all this is doing here is finding the center point of whatever table we're going to create. We're assuming that it's going to be 60 characters wide. Then we're going to put, remember at L, that means put at a particular point in the table. So it moves the cursor over to the spot L, and it's going to enter the table head. The table head is this here, summary of grades. So it's going to put the header right there. Then the next line, it's going to move over to the 5th column, and it's going to put a bunch of equal signs, in fact 60 of them. Then the next line is going to move to the 5th line and put the word name. Then it's going to move to the 20th line, put a vertical bar, test 1, go to the 30th line, vertical bar, test 2, and so forth. So it's creating a table is what's happening here. And then finally at the end, it goes to the 5th line and creates a single bar that's 60 columns wide, and then end. So at the very first of the program, it creates basically a header for the table that we're going to be using. Now part 3. So that was the header. Now we're looking at the guts of the report. So in the guts of the report, we're going to move to column 5. Again, move to and then so enter the name of the person. Then move to column 20, enter their grade, formatted. Go to column 30, enter grade 2, formatted, grade 3, formatted, and average. And it's going to continue to do that. But if it hits the end of file, then again, here's a do. So if at the end of the file, it's going to put a footer for the report. So it's going to enter all the people in the class. It's going to have one line for each person in the class. But for the last person in the class, after the last person in the class has been listed, then it's going to put a footer in here. And this footer is going to contain a line, and then the word class average, and then it's going to put the class mean here, and again a dashed line. And this is going to display the summary information, which includes this macro variable that we created called class mean. Remember, we created this class mean, and that's the variable we created so that we would know what the mean of the class grades are. And so here we have the result. We created this header, and then we created the body of the table, and then we created this footer. So we had three parts that we created: header, body, and footer. So if you go back and look at the program, I think it'll make sense to you. But the whole idea here is you can create any customized report that you want to using these put statements to define what you want your program to look like. And you get very creative. This is a fairly simple one with dashes, but you can actually use much more interesting lines and that fit together and make it look very nice if you want to. All right, so just as an example, add a new student to the data and rerun to see how the table adapts to the new information. So this table will expand ad infinitum, as you enter new students. So we've created a generalized program, and you can add as many students as you want. We can change the format for the student averages to 6.2 if we want to, and see how that would also run correctly. All right, this concludes the main chapters in the text, but I would also encourage you to look at the appendices because they have valuable information. Appendix A includes options of references such as colors, lines, and patterns that we've referred to throughout the text. Appendix B includes SAS function references. Appendix C includes choosing SAS procedures, like what procedure should I use, a t-test, a chi-square, for instance. Appendix D gives you SAS code examples. Appendix E shows you how to use the online free internet version of SAS. And Appendix F shows you how to use the is a SAS-based example test that you can use to try out your skills in SAS. We hope that you've enjoyed these tutorials. I would ask that if you like these tutorials, that you subscribe to this channel and give us a thumbs up. Thanks for watching.